There's a powder sitting quietly on a shelf in almost every hardware store. Most people walk past it without even noticing. It costs about $3, and according to builders who have known about it for centuries, it can eliminate humidity without electricity, without machines, and without filters. No humming motors, no maintenance contracts, no monthly energy bill, just a simple white powder. Place it in an open container, and the air slowly begins to change. Moisture begins to disappear. Mold stops spreading. Walls slowly start to dry out. And over time, the water that once floated invisibly in the air becomes something solid. Rock. The process requires no modern technology. No wires, no complicated systems, just chemistry quietly doing its work. The strange part is not that this method exists. The strange part is that almost nobody talks about it. Yet engineers have used it for more than a century. Military bunkers used it. Victorian railway tunnels used it. Even ancient builders unknowingly relied on the same chemical reaction. And the science behind it is surprisingly simple. One compound. Calcium hydroxide, also known as hydrated lime. To understand why this humble powder matters so much, we need to go back thousands of years. Long before electric dehumidifiers existed, civilizations were already trying to control moisture. Humidity has always been one of humanity's oldest building problems. Water seeps into stone, rot spreads through wood, and invisible moisture slowly weakens walls from the inside. Ancient civilizations faced the same challenges modern homeowners face today, but instead of machines, they relied on materials from nature. One of those materials was lime. The ancient Romans used lime extensively in construction. Their aqueducts, baths, and underground structures depended heavily on lime-based mortars. Roman engineers noticed something unusual. Buildings constructed with lime-based materials often remained far drier than expected, even underground, even near water, even in humid climates. The Greeks had noticed similar effects centuries earlier. They used lime plasters inside storage rooms and stone buildings. Many of these spaces resisted dampness far better than untreated stone structures. Across the Mediterranean world, builders began noticing that lime behaved differently from other materials. It was not simply holding stones together. Something about it interacted with the surrounding air. But the real explanation would not arrive for nearly 2,000 years. In the early 1800s, a chemist in England began examining this old building material more closely. His name was Edward Dobson. Dobson was a Quaker engineer and chemist working during the early Victorian era in London. At that time, Britain was expanding its railway system at an incredible pace. Thousands of miles of tunnels were being carved through rock and soil. But those tunnels had a problem: moisture. Underground air carried enormous humidity. Water condensed constantly on tunnel walls. Minerals seeped through the rock. And over time, the structures began deteriorating. Engineers needed a solution. Dobson began studying lime more carefully. Instead of simply using it as mortar, he examined how it reacted with air itself. What he discovered was simple but powerful. Hydrated lime reacts with carbon dioxide in the air. When moisture is present, the reaction speeds up. During this process, calcium hydroxide slowly transforms into calcium carbonate. In simple terms, lime slowly turns into limestone. But something interesting happens during that transformation. Moisture molecules become trapped inside the forming mineral structure. The water does not simply evaporate. It becomes chemically locked inside the stone. This reaction is called carbonation, and once it occurs, it cannot easily reverse. Dobson realized something important. If hydrated lime was placed in humid environments, it could gradually remove moisture from the air while transforming into solid stone. He published his findings. Engineers began experimenting with the idea. The results surprised them. Victorian railway builders started placing hydrated lime inside sections of tunnel systems. They packed it into wall cavities. They used it inside ventilation chambers. They mixed it into mortar in certain areas. Then they waited. Months passed, then years. Engineers began noticing a pattern. Sections treated with hydrated lime stayed noticeably drier than untreated areas. Condensation was reduced. Seepage slowed down. Mineral deposits appeared less frequently. Some tunnels built in the mid-1800s are still dry today, more than 170 years later. No machines, no electricity, just chemistry slowly doing its work. Over time, this principle spread to other construction projects. Bridge foundations used it. Canal systems used it. Underground storage vaults used it. Military engineers later used similar techniques in bunker construction. For decades, the knowledge quietly existed inside engineering and construction practices. But the 20th century changed how buildings were managed. Electric technology expanded rapidly. Fans became common. Compressors and refrigeration systems appeared. Eventually, electric dehumidifiers entered the market. These machines could remove moisture quickly, but they required power. They required maintenance, and they needed to run continuously. Once switched off, humidity returned. Around the same time, a massive industry formed around moisture control. Waterproof coatings, drainage systems, sump pumps, basement sealing services, commercial dehumidifiers. Entire companies were built around solving humidity problems. Today, the waterproofing and humidity control industry generates billions of dollars each year. Many homeowners spend thousands trying to control basement moisture. Excavation work alone can cost several $1,000s. Commercial dehumidifiers cost hundreds. Electricity bills increase every month they run, and yet many humidity problems continue returning, because machines often treat the symptoms rather than the underlying environmental conditions. Long before these machines existed, builders had already discovered passive approaches, methods that required no electricity, no motors, no compressors, just chemistry. If you enjoy exploring forgotten engineering knowledge like this, welcome to the channel. Here we look at ideas history nearly buried, ancient building techniques, lost scientific tricks, and the surprising chemistry behind materials our ancestors used centuries ago. If that sounds interesting, consider subscribing, because many of these discoveries are stranger than they first appear. Hydrated lime was not only used in Britain. Evidence of similar practices appears across different civilizations. In ancient Egypt, lime-based plasters were used inside tombs and underground chambers. Many of those chambers remained dry for thousands of years. Roman engineers refined lime mortars even further. Their concrete structures still survive today largely because of lime chemistry. Across Asia, Chinese builders also used lime mixtures in walls and foundations. In India, lime plaster appeared in palace construction and storage buildings. Across the Middle East, traditional builders used lime coatings in humid environments. Different continents, different cultures. Yet the same material kept appearing again and again, lime. For centuries, builders repeatedly noticed its unusual properties. But the chemistry behind those observations would only be explained much later. Hydrated lime is calcium hydroxide. When exposed to carbon dioxide in the air, it slowly reacts. The reaction converts calcium hydroxide into calcium carbonate. Calcium carbonate is simply limestone. Humidity actually helps accelerate this reaction. Moisture in the air participates in the transformation. As the reaction continues, mineral crystals form and harden. During this process, water molecules become incorporated into the structure of the new mineral. In effect, vapor from the air becomes part of solid stone. And once locked into calcium carbonate, that moisture is no longer floating in the air. It has become part of a rock, a passive chemical trap created by nature itself. No electricity required, no moving parts, just a slow chemical transformation. Modern building science has started re-examining passive humidity materials. Some controlled experiments have shown significant reductions in humidity inside enclosed spaces using mineral desiccants. Mechanical dehumidifiers, by comparison, often require hundreds of watts of power to operate continuously. Running such machines daily can cost hundreds of dollars in electricity each year. Passive mineral materials cost only a few dollars, but they work slowly. Chemical reactions take time. Machines provide instant results. Chemistry provides gradual results. That difference may explain why mechanical systems dominate modern markets. Immediate solutions sell more easily. Slow natural processes attract less attention. There is another reason. Simple solutions sometimes disappear from everyday knowledge. Modern construction industries rely heavily on standardized supply chains. Materials are categorized by professional use. Hydrated lime is usually classified as a construction material. It is often placed in masonry or contractor supply sections of hardware stores, not in consumer humidity aisles. So many homeowners never encounter it while searching for moisture solutions. Instead, they see machines, chemical sprays, professional service packages. None of this necessarily means simple methods were intentionally hidden, but markets naturally favor products that can be sold repeatedly. Machines need power. Machines wear out. Services must be renewed. Passive materials used once generate little ongoing revenue, so attention slowly shifts toward more profitable systems. Meanwhile, the old materials remain quietly on store shelves. Consider the scale of moisture problems today. Environmental agencies estimate that a majority of homes experience some level of humidity or moisture issue. Basements, crawl spaces, closets, or storage rooms. When humidity rises above 60%, mold begins to thrive. Many homes spend years battling this cycle. Dehumidifiers run constantly. Electricity bills climb higher. Contractors install expensive waterproofing systems. Yet moisture often returns, which raises an interesting question. If simple mineral materials can gradually remove humidity, why are they rarely discussed in modern solutions? For those curious enough to experiment, the practical method is extremely simple. Purchase hydrated lime from a hardware store. Look for labels such as calcium hydroxide, mason's lime, or hydrated builder's lime. Avoid agricultural lime and quicklime. The compound must specifically be calcium hydroxide. Place the lime inside a wide, shallow container. An aluminum tray works well. Fill it roughly 2 inches deep. Then place the tray in the area where humidity is strongest. Basements, crawl spaces, closets, docked storage rooms. Leave the container uncovered so air can reach the lime. Over several weeks, the surface may begin forming a thin, hardened crust. This indicates carbonation has started. Eventually, the material may harden into a solid block. At that point, the chemical reaction has largely finished. The hardened mass is essentially limestone. It can be discarded outdoors and replaced with fresh lime if desired. Large areas may require multiple trays. Older building guides sometimes suggest one tray for roughly every 100 square feet, because humidity tends to collect near the ground. Trays should remain at floor level, and since lime is alkaline, wearing gloves when handling it is recommended. Looking back across history, a clear pattern appears. Romans used lime, Victorians used lime, military engineers used lime. Builders across continents relied on the same material, all because its chemistry interacts with moisture in ways few materials can. Yet today, many homeowners only encounter expensive machines and complicated systems. Some require continuous electricity, others require major construction work. Meanwhile, a simple bag of hydrated lime still sits quietly on hardware store shelves, exactly where it has always been. Knowledge rarely disappears completely. More often, it simply moves from everyday practice to specialized knowledge, to forgotten footnotes in engineering history. Hydrated lime never vanished. Its chemistry never changed. But as industries evolved, attention shifted toward faster and more profitable technologies. Machines replaced materials, services replaced simple techniques, and gradually the older knowledge faded from public awareness. Yet the science remains the same. Calcium hydroxide still reacts with carbon dioxide. Carbonation still forms limestone. Moisture can still become trapped inside mineral structures, exactly as it did in Roman walls, Victorian tunnels, and military bunkers built more than a century ago. Sometimes, the most fascinating discoveries are not new inventions. They are old ideas quietly waiting on a shelf, hidden in plain sight. And once you know where to look, you begin to realize how many forgotten techniques the modern world has left behind.